Flows are performed art that involve spinning glow sticks on strings to make pretty patterns. Kicking, on the other hand, is an Estonian sport known as extreme swinging because participants attempt to swing themselves over the top of a swing. So what could they possibly have in common? Well, both activities involve circular motion, so let's compare them. Let's start calculating the speed of the glow sticks as they're being spun around. To do this, we need to figure out how many times it will take for our test subject to spin the glow sticks 10 cycles. It took an average of 7.11 seconds for her to spin 10 cycles, which gives us a period of about 0.711 seconds. To calculate the speed, let's take the distance the glow sticks travel in one cycle as circumference and divide by the period. Doing so gives us a speed of 2.7 meters per second. Next, to calculate the net force of the glow sticks, we need to calculate the centripetal force. We know the length of the string is 0.31 meters and the mass of the glow sticks is 0.024 kilograms. Plugging these numbers into the equation Fc equals mv squared divided by r gives us a centripetal force of 0.564 newtons. This is Kaspar Timesoo, the world record holder for kicking. Pretty cool, right? Kaspar Timesoo swung around the bar with an impressive record-breaking 7.15 meter long swing shaft. To calculate the speed, we'll use the same method. The total distance traveled by Timesoo is about 44.9 meters. Divided by the 6.85 seconds to spin one revolution gives us a speed of about 6.56 meters per second. To find out the centripetal force, we know its mass is 94.6 kilograms, which is not a world record, but plugging these numbers into the centripetal force equation will give us a net force of 880 newtons. So what if our test subject wanted to spin glow sticks with the same force that Timesoo exerted kicking? How fast would she have to spin them? To find out, let's set Timesoo's centripetal force equal to the centripetal force equation using the glow sticks as the mass and rearrange. Once we do this, the speed turns out to be 86.6 meters per second, which means that a test subject had to spin her glow sticks 83.9 meters per second faster in order to match the force that Timesoo exerts. Put this number into context, the glow sticks have to travel at a speed slightly less than the typical speed of a bullet train, which is extremely fast. You'll never be able to flow at that speed, which just goes to show this entire experiment was pointless.